In this video, we are again tasked to run a code with the help of AVR Studio 4, and this code is already available, and we are just tasked to write them and observe the flags as well as the status registers. And so now let's create a new project. Select Atmel AVR Assembler, and let's rename this project as Activity 2 since this is our second task. And after this, click next, and then we choose the AVR simulator, and our device is at Mega 32 again. Then click the at Mega 32 and then click finish, and let's wait for the IDE to load. And so this is our IDE, and let's expand this one since we needs much space for our code. And I will try to type in our code, and for you to see what is the problem being solved, just look at the description. But for you to have an idea, no, we are just given with a code, and we are just tasked to examine the status register as well as the flags on it. And now, since we are done with the writing of our code, we can now assemble this code for us to verify if there are errors or there are no errors. And unfortunately, there are errors, and as I look at the code, it is the ly RJMP here line, wherein I have mistakenly written here instead of L1, so I just need to replace it as L1, and then we can now again assemble this code. And now, since there are no errors or warnings for our code, we can now assemble and run or enter in the debugging mode. And as we are in the debugging mode, here's our registers. Expand them to see the registers, and we can now use the step info to examine the register as well as the flags. And since we know that the flags doesn't change values on the LDI instruction, so we can now focus on the sub instruction, wherein there will be changes or not with the ZHZ flags or the other flags that we are going to examine. And as we are done with the first sub instruction, it is observable that there are no other flags that changes value from 0 to 1, meaning that this after the subtraction of the register R20 and R1, there are no changes with our flags. As we skip with the another LDI instructions, and as we monitor with the second sub instruction, the status register has turned on the half carry flag, meaning that the resulting value after subtracting R20 and R1 has exceeding the 4-bit or the lower nibble of the 8-bit status register. And after skipping another LDI instructions for R24 and R25, we are focusing with the third sub instruction, which is subtracting the values of R24 and R25. And our flag, the 0 flag, has been turned on, meaning that the previous instruction or the previous operation sub instruction has the resulting value of 0. That is why the Z flag is turned on. For the last sub instruction, as the R22 and R23 are being subtracted, our flags H, S, N, and C flag are turned on, meaning that the resulting value of this subtraction has exceeded the 8-bit of the status register, as well as the lower nibble of the 8-bit register has exceeded the 4-bit value. And now, after examining the status register, we can now also examine the registers and observe their values. For the LDI instruction, obviously, we are just going to load the values that is given by the code. And for the sub instruction, it is going to subtract the hexadecimal values that has been loaded in the register given. Just like in the early instructions, no, as we loaded 27 and 15 respectively with R20 and R21, as we call on the sub instruction 27 minus 15, it executes as 12 hexadecimal. And I guess that would be all, and thank you for watching this video.